For any square matrix, in general, if the order is n, then determinant of Ka can be written as k to the power n into determinant A. Since we are finding the coordinates here, the value of k may be positive or negative. So when any unknown elements are finding inside the determinant, you can use plus or minus here for the area. Determinant of adjoint A is always equal to determinant A times to the power n minus 1, where n is the order of the matrix. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So today in this session, we are going to revise the chapter Determinants. Here in this chapter, let's see the important types of questions in each section. So you will be having one multiple choice question, one fill in the blank question, one 2-mark question, one 5-mark and one 4-mark question. So overall, you can expect 13 marks from this chapter. So basically, MCQ and fill in the blanks will be on the definition and simple problems related to the determinants, and 2 marks is from the area of a triangle. That is, either you have to find the equation of a line or the problems related to area of a triangle using determinants, and 5-mark question will be on the system of simultaneous linear equation by matrix method, and the last 4-mark question will be finding A inverse using matrix equation. So let's take few problems, important questions related to this chapter. So we have objective questions here. The first question is determinant of 3x x1 is equal to 3, 2, 4, 1. Then value of x is 2, 4, 8 plus or minus 2 root 2. So here they have given two determinants are equal. So obviously their value will be equal. If we solve these determinants simultaneously, we will get 3 minus x square is equal to 3 minus 8. So we will get x square is equal to 8. X is equal to plus or minus root 8, which can be written in the form of 2 root 2, because 8 can be written as 4 into 2, and 4 you can take out of the square root. So the correct option is plus or minus 2 root 2. Next we have, if A is a square matrix of order 3 cross 3, then determinant of Ka is k into determinant A, k square into determinant A, k cube into determinant A, 3k into determinant A. Suppose when we multiply any scalar to the matrix, let's take, we have A, B, C, C, D, E, F, G, H, and we have multiplied k to all the elements inside the matrix. So when we are taking the determinants, we will be having k in all the 3 rows. So it is k into k with respect to determinant. So k cube into determinant A. So basically the order of a matrix is 3 cross 3. Hence k into determinant A will be equal to k cube into determinant A. So for any square matrix, in general, if the order is n, then determinant of Ka can be written as k to the power n into determinant A. So using this, we can write this as k cube into determinant A. Next, if A is an invertible matrix of order 2, then determinant of A inverse is equal to determinant A 1 over determinant A 0 or 1. So let's take one simple definition, that A into A inverse is equal to I. So using the definition of inverse of matrices, let us apply determinant on both sides. Now determinant of A into B, matrix A into B, can be separately written as determinant A into determinant A inverse, and determinant of your unit matrix is always equal to 1. So here we need determinant of A inverse, so hence this can be 1 over determinant A. So the correct option is 1 over determinant of A. Next, if A is a square matrix of order n, then determinant of adjoint A is equal to determinant A to the power n, determinant A to the power n minus 1, n into determinant A. So basically, determinant of adjoint A is always equal to determinant A times to the power n minus 1, where n is the order of the matrix. For instance, if the determinant of a square matrix is 3, then determinant of adjoint A will be equal to determinant A to the power 3 minus 1, which is equal to determinant A square. So this is an example, and in general we can write the determinant of adjoint A as determinant A to the power n minus 1. Next we have the inverse of the matrix 2, 2, 4, 3 A's. So here they have given a 2 cross 2 matrix. We know that inverse of the matrix is given by 1 over determinant A into adjoint A. So here adjoint A. So for 2 cross 2 matrix, to find the adjoint A, we can interchange this and we can change the sign of this. So what we will get? 3 minus 2 minus 4, 2. And 1 over determinant A means determinant of this matrix is 1 over 6 minus 8, which will be minus 1 by 2 of 3 minus 2 minus 4, 2. So here we have 1 by 2, 3 minus 2 minus 4, 2, 1 by 2 minus 3, 2, 4 minus 2, 1 by 2, 3, 2, 4, 2, 1 by 2, 3, 4, 2, 2. So the correct option includes minus half. So none of the options here is having the sign. So but this is almost relatable. 1 by 2, 3 minus 2 minus 4, 2. So we are missed with negative sign here. So that is the correct options. Next type of question under 2 marks. Using determinants, find the equation of the line passing through the points 1, 2 and 3, 6. So to find the equation of the line, so we will use the determinant, and the first row can be taken in the form of x, y, 1. The second row is taken as 1, 2, 1. The third row is taken in the form of 3, 6, 1. So the last column is 1, 1, 1. The rest of the things can be taken as x, y, 1, 2, 3, 6. So that is equal to 0. So then we can expand the determinant. So x into, so deleting the row and the column. So take the determinant of 2, 1, 6, 1. So which will give you 2 minus 6. Next we have minus y, deleting the column and the row, we have 1, 1, 3, 1, which is 1 minus 3. The last one we have 1. So for 1, deleting the column and the row, we have 1, 2, 3, 6 in the form of determinant. So it is 6 minus 6, which is equal to 0. So here we'll get minus 4x, minus into minus, plus 2y is equal to 0. Or we can write 2y is equal to 4x. Or y is equal to 2x. So this is the equation of the required line. Next, find the value of k if area of the triangle has 4 square units and vertices are minus 2, 0, 0, 4 and 0, k. So they have given the area of the triangle. So we know that the area of the triangle is given by delta is equal to 1 by 2, determinant of x1, y1, 1, x2, y2, 1, x3, y3, 1, where x1, y1, x2, y2, x3, y3 represents the vertices of the triangle. So here they have given the vertices of the triangle. Also the delta is given. So that is 4. So we will write here 4 is equal to 1 by 2, determinant of minus 2, 0, 1, 0, 4, 1, 0, k, 1. So now here, since we are finding the coordinates here, the value of k may be positive or negative. So when any unknown elements are finding inside the determinant, you can use plus or minus here for the area. So now here it becomes plus or minus 8 because 2 4s are 8. So here when you calculate the determinant, I'll go with column wise. So we have minus 2 into 4 minus k. Then we have minus 0 plus 0 because 0 into determinant plus 0 into determinant is again 0 here. So we can clearly see here we have plus or minus 8 is equal to. So when we multiply minus 2 into 4, it is minus 8 plus 2k, or we can write 2k is equal to plus or 8 minus 8, or k is equal to plus or minus 4 minus 4. So k can be 4 minus 4 or k is minus 4 minus 4. So therefore k is equal to 0 or k is equal to minus 8 is the answer. Next question. Using determinants, find the area of the triangle whose vertices are -2, -3, 3, 2, -1, -8. So directly we can calculate delta is equal to 1 by 2. Let's substitute all the vertices inside the determinant. We have -2, -3, 3, 2, -1, -8. The last column in the form of 1, 1, 1. Now we have 1 by 2. So -2, we are taking the minus and the determinant form of 2, 1, -8, 1 here. So 2 1s are 2 plus 8. Next we have minus of -3 will become +3. So deleting the column and the row, we have 3 1s are 3. Minus into -1 become plus. Next we have +1. Again deleting the column and the row, we have 3 8s are. So -24 plus 2. So next we have 1 by 2 outside. 10 2s are -20. So 3 plus 1 4. 4 3s are 12. Next we have -22. So if you add and simplify, so you will get the value as -30 divided by 2. So which is -15. Since we are talking about area, so the area is always positive. So the value is 15 square units. Next question, under 5-mark question. So we have here the simultaneous linear equation. So we need to find the solution of this x, y, z using matrix method. So when the linear equations is given, we will separate matrix A, matrix X and matrix B using x is equal to A inverse B. We can find the values of x, y and z. So let's write matrix A first. Matrix A is the coefficients of the variable here. So that is 2, 3, 3, 1, -2, 1, 3, -1, -2. And the matrix values which contains x are the variables x, y, z. And matrix B contains the constant, that is 5, -4, 3. So according to the definition, before finding the inverse of a matrix, let's see whether it exists or not. So we will check the determinant A. So if the determinant A is not equal to 0, that means if matrix A is non-singular, then inverse of the matrix exists. So let's check here. So we have 2, -2 into -2 is 4, plus -1 into 1. Next we have -3. So for -3, we have -2, -3. Next, we have the last as 3. So for 3, we have -1 plus 6. Now 4 plus 1 is 5. 5 2s are 10. -5 -3, 15. Next, so 5 3s are 15. So determinant A is equal to 40 here, which is not equal to 0. So what we can confirm here? We can say that A inverse exists. Once A inverse exists, we are going to find out A inverse. And how to find A inverse? A inverse is always 1 over determinant A into adjoint A. So that means we need to find out the adjoint for the given matrix. So to find the adjoint, we need the cofactors. So that cofactors are the minors of the each element. So we'll calculate A11, A12, A13. So we'll take the sign plus, minus, plus. So the first 3 are already written inside the determinant value. So 4 plus 1, 5. Next we have -2, -3, which is -5. That is equal to 5. Next we have -1 plus 6. That is 5. So here also it is 5. Let's find the remaining one. So we are calculating A21, A22, A23. Minus, plus, minus. Let's calculate for A21. Now for A21, so this is the element. So let's find the minus of this. We have 3, 3, -1, -2. That is 3 into -2, -6 plus -1, 3 is already minus 3. So minus of minus 3 is 6. So we'll write this 3 into minus 2 is minus 6 minus 1 into 3. So which is minus 3, which becomes plus 3. So minus 6 plus 3 is minus 3. So outside we have minus. So this is 3. Next we'll calculate for minus 2. So what are the minus? 2, 3, 3, minus 2. So we have minus 4, minus 9. Minus 4, minus 9, which is equal to minus 13. Next for the element 1. So delete the row and column. We have 2, 3, 3, 1, which is 2 into minus 1, minus 2, minus 3 3s are 9. So we have minus 2, minus 9, which is equal to plus 11. Next we are going to find out A31, A32, A33. So remembering the sign, the last one is negative. So we'll put plus, minus, plus. So let's find A31 now. So for A31, delete the column and the row. We have 3, 3, minus 2, 1. So 3 1s are 3, minus, minus 6. So which becomes 3 plus 6, which is equal to 9. Next we have for minus 1, delete the column and the row. 2 1s are 2, minus 3. So we have 2 minus 3, which is equal to minus 1 into minus plus 1. Next, the last one is for 2. We have 2 minus 4 minus 3. So minus 4 minus 3, which is equal to minus 7. Now let's write the adjoint A in the order. So we have adjoint A. So let's write it in the form of A11, A12, A13. That is 5, 5, 5. Let's write it column wise. Then we can reduce one more step of taking the transpose of a matrix. So let's write it as 5, 5, 5. Next we have 3 minus 13, 11. 3 minus 13, 11. Next we have 9, 1 minus 7. So 9, 1 minus 7. Now, let us use the equation x is equal to A inverse into B. So, what is x we have taken? We have taken x as x, y, z. And A inverse is 1 over determinant A into adjoint A into B. So, let's take this 1 over 40. Adjoint A is 5, 5, 5, 3 minus 3, 11, 9, 1 minus 7. And B is 5 minus 4, 3. 5 minus 4, 3. Now let's multiply these two matrices. So we have 1 by 40. So here it's row into column. So 5 5s are 25. Next minus 12 plus 27. Next 25 minus into minus plus 13 4s are 52 plus 3. Next we have 25 minus 44 minus 21. So evaluating this, we'll get 1 by 40, 40, 80 minus 40. Let us divide each element by 40. Then finally, we'll get the value x, y, z as 1, 2, minus 1. So clearly, x is equal to 1, y is equal to 2, and z is equal to minus 1. So this type of solving the simultaneous equation is called as matrix method. Next, we are moving for 4-mark section. So under 4-mark question in your examination, you can expect a one question from continuity and differentiability. So basically, it will be on the continuous function. The other one will be from the determinants. So here is one type of question you can expect for 4 marks. Now show that the matrix A is 2, 3, 1, 2 satisfy the equation A square minus 4A plus I is equal to O. O means null matrix. I is the identity matrix of order 2 cross 2. Now we have to verify whether it satisfies the given equation, that is the matrix equation, and using that equation only, we are supposed to find A inverse, not using the formula. So here clearly they have mentioned using this equation, that means using this matrix equation only, we have to find out A inverse. So before that, let us see whether it satisfies the matrix equation. So let's find A square first. So A square 2, 3, 1, 2. 2, 3, 1, 2. So let's take row into column. So 2 2s are 4 plus 3 1s are 3. First column is done. Let's move on to the second column. 2 3s are 6 plus 3 2s are 6. Next with the second row. 1 2s are 2 plus 2 1s are 2. 1 3s are 3 plus 2 2s are 4. So we have matrix A square as 7, 12, 4, 7. Now let's see what is 4a. That means you need to multiply 4a here. So let us consider the equation a square minus 4a plus I. So what is a square? We got 7, 12, 4, 7. Let's write here 7, 12, 4, 7. Minus 4a. That means you need to multiply 4 to the given matrix A. So our A is 2, 3, 1, 2. So when you multiply 4, it is 4 2s are 8, 4 3s are 12, 4 1s are 4, 4 2s are 8. The last is I. So that is 1, 0, 0, 1. Now let's see here. 7 minus 8 is minus 1. Minus 1 plus 1 is 0. 12 minus 12, 0. 4 minus 4, 0. 7 minus 8 plus 1 is 0. So therefore, it is satisfying the given equation. Now let us consider the equation a square minus 4a plus I is equal to 0. So keeping I here, I'll move the rest of the things to the right hand side. So what I'll do here, I'll take a as a common factor. Then I'll get 4 minus a. So I is equal to a into 4 minus a. Now we have this equation. Let's multiply a inverse or pre-multiply a inverse on both sides. Then I'll get a inverse into I, a inverse into a, 4 minus a. So a inverse into I is A inverse only. A inverse A is always identity, that is I, 4 minus A. Now A inverse is equal to 4 into I minus A into I is A itself. So we have A inverse, 4I means 4, 0, 0, 4. Matrix A is given as 2, 3, 1, 2. Therefore, A inverse is equal to 4 minus 2 is 2, 0 minus 3 is minus 3, 0 minus 1 is minus 1, 4 minus 2 is 2. So this is the inverse of the given matrix. Now you can also verify the inverse of the matrix using this formula, that is 1 over determinant A adjoint A. So using this formula, if your answer is same as this, you can also verify it. But here in the question they have mentioned using the equation. So therefore you are not supposed to use the formula method here. So you have to use the equation, and theoretically you need to prove A inverse is the 2 minus 3 minus 1 and 2. So here in this session we have learned few important questions on this chapter. So in the next session we'll meet you with the new lesson. Until then, keep watching, keep learning, keep exploring. Thank you.